All right, note card, note card. Get out your note card. And label it half-angle identities. All right. The sine of 1/2 x equals positive or negative. That's supposed to be a negative. Equals positive or negative the square root of 1 minus the cosine of x over 2. The cosine of 1/2 x equals positive or negative 1 plus the cosine of x over 2. So sine is minus and cosine is plus. And tangent is sine over cosine. So it equals positive or negative the square root of 1 minus the cosine of x over 1 plus the cosine of x. But we don't use that one very often. Instead, there's two others that we use more often. One of them is sine of x over 1 plus the cosine of x. The other one is 1 minus the cosine of x over the sine of x. And probably the last one is the one I use most often. All right, half-angle identities we actually, kind of sort of need, unlike the double-angle identities. Double-angle identities, you just have to kind of go through the motions. Half-angle identities, we actually use a little bit. So, let's find the sine of 5 pi over 12. Well, 5 pi over 12 is half of what? Half of what is 5 pi over 12? 10 pi over 12, which is 5 pi over 6, right? Because 5 pi over 6, if you take 2 times 6, is 12, okay? So that equals, now, where is 5 pi over 12? What quadrant is that in? Where do you think 5 pi over 12 would be? Is 5 pi over 12 less than 6 pi over 12? Where's 6 pi over 12? 90 degrees, right? So 5 pi over 12 would be less than 90, which would be quadrant 1. So it's going to be positive. So see where it's plus or minus? It's just going to be positive. It's going to be the square root of 1 minus the cosine of 5 pi over 6 over 2. Which equals the square root of 1 minus the square root of 3 over 2 over 2. Oh no, we've got a fraction with a fraction in it, otherwise known as a complex fraction. How do we get rid of a complex fraction? Well, we're going to multiply by the denominator of the numerator because that's the only denominator I see, right? Yeah. So we're going to multiply everything by 2 on the top and the bottom. So we get the square root of 2 minus the square root of 3 all over 4. See what just happened there? Well, no, you can't because it went off the screen. Okay, so 2 times 1 is 2. Square root of 3 over 2 times 2 is square root of 3. And 2 times 2 is 4. Multiply top and bottom by 2. Now, can you leave a square root in the denominator? No, and when you have a square root over a whole fraction, it's like having a square root in the denominator. So we will finally go to this as our final answer. And yes, it is possible to leave a square root inside of a square root. So that's our final answer. It'll look like that. So 2 minus the square root of 3 all over 2. Let's do another one. The cosine of 13 pi over 12. What quadrant would I be in? I'm going to be in quadrant 3. Cosine will be negative. So I'm going to use the cosine of 1/2 of 13 pi over 6. All right, now you're going, what's 13 pi over 6? What did we do on the very first day of trig class? We got our books. After getting our books, well, we found coterminal angles, right? Very first thing we did, coterminal angles. What's coterminal with 13 pi over 6? 1 pi over 6. So this is the same as cosine of 1 pi over 6. What's cosine of pi over 6? Square root of 3 over 2. So it's 1 minus square root of 3 over 2. Nope, it's 1 plus square root of 3 over 2. Sorry about that. All over 2. And this will be negative in the end, so I need to put a negative out front. What's the quick and dirty way of solving this? Multiply all by 2. So it's negative the square root of 2 plus the square root of 3 over 4, which is negative the square root of 2 plus the square root of 3 all over 2. And here we are, we're done. Let's do a tangent one. Tangent of pi over 12 equals the tangent of 1/2 of pi over 6, which equals, if we go up to the tangent ones, I like this last one the best. 1 minus the cosine over the sine. So 1 minus the cosine of pi over 6 over the sine of pi over 6. So when you substitute this, not the original one, because the original one is not on your unit circle. That's why we're doing this. So it's 1 minus the square root of 3 over 2 over 1/2. What do I have there? Oh, complex fraction. How do I get rid of a complex fraction? Multiply by the denominator of the denominator. So you get 2 minus the square root of 3 over 1, which is just plain and simple 2 minus the square root of 3. Are we good? Is 3 examples enough, or do you need some more? 3 is good? Okay, let's see what we're doing. What are we doing? We are doing... I better look at my book. I still don't know what I assigned Aiden, but... Let's do on page 193, 9, 11, 13, 14, 15, and 17. That's 6 problems. 115.